the notes for AP Calculus on the topic of real-world rate of change problems continued. Okay, so this one says we've got a population of goblin sharks in the ocean is modeled by a differentiable function g of time where g of t is the number of goblin sharks, and t is measured in years from 0 to 50. And it says there are 500 goblin sharks in the ocean at time 0. And the birth rate for the goblin sharks in the ocean is modeled by the function b of t. And notice the units are goblin sharks per year. And the death rate for the goblin sharks in the ocean is modeled by the function d of t. This is also goblin sharks per year, but this one is what makes it a little more challenging here. It's a piecewise function. This first piece only applies for the first 30 years, and the second piece applies from years 30 to 50, the last 20 years. So part A says write a piecewise defined function, so they give you a clue, it's got to be piecewise, for g of t, which remember they told us is the number of goblin sharks. So at time t. So to write a function for g of t, notice the first thing we'd have to account for is how many goblin sharks are in the ocean to begin with, and so that's our initial amount. And we'll need two pieces of this because d of t has two pieces to it. So we'll have g of t equals, then we'll put the open brace here, or two different pieces. The initial on both of them is 500, plus the change, so these are really initial plus change formulas. The change comes from the definite integral of the derivative. But we've got two components to the derivative, the rate of change of the goblin sharks. We've got the birth rate, which increases the amount of goblin sharks, and the death rate, which decreases the amount of goblin sharks. So this first integral here, the lower limit would be wherever your initial is at, which oftentimes, but not always, is 0. So that'd be from 0. And then we want to be able to use it for any time t. So t would actually be our upper limit here. And let's first look at the one where we just would use the top piece, if we're somewhere between 0 and 30 years. So for this one, the overall rate of change derivative is what has to go inside the integral. So we've got the birth rate b of t. You could write 30e to this, or this one is not piecewise, so it's always the same, no matter what interval we're looking at. So you could just write b of, but rather than t, remember we only want to substitute in the time for the upper limit here. So you have to switch the variable. It stays the same function, but switch the variable to something like x, so b of x. All that means is it would be 30e to the 0.005x instead of t, same function. And then minus d of t, but here we can't just write d of x, because if you just write d of x, it's not clear which piece you'd end up using. Okay? So we have to specify that. In this case, since we're just looking up until time 30, it would just be this function. So we would write that as 44e to the negative 0.02, again, x instead of t. And then times dx instead of dt. These are in terms of x. So that way, now, well, let's write the last part of this one. This applies on the interval for 0 less than or equal to t less than or equal to 30. So if our time we're trying to figure out the number of goblin sharks at a time between 0 and 30, let's say 20. You would put in 20 right here, 20 here, and they would tell you the initial is 500 plus what's the change from 0 to 20. Now let's look at the second piece. We'd still have to include the initial, but this one's a little bit more complicated. Because if we're beyond time 30, let's say time 35 or 40 or something, you can't just ignore this first piece of the death rate function, because this one still applies over the first 30 years. So let's account for those first 30 years first by going from 0 to 30. And then we'd still have b of x, same thing we had here, minus the first piece, 44e to the 0.02x times dx. So this would tell you the initial is 500, and what's the change on those first 30 years of the number of goblin sharks. However, now we're going to be looking for, well, what happens beyond time 30? So that's where we need another integral. This one wouldn't start at 0, though. It would start at 30. That's where this second piece of the DFT function kicks in after you're 30. And the upper limit here would be t, because that way we can find, well, what's the change in the number of sharks from 30 to, let's say, 35 years, or 30 to 40 years. And we've already accounted for the first 30 years in the first interval. And so b of x, again, can stay the same, because that's not piecewise. But again, you can't just put d of x, because it wouldn't be clear which piece you're using. Now here we've got to use the second piece. So there's two terms to it, so you have to put in parentheses minus 35 cosine of t over 14. Oops, not t, sorry, x. Got to switch the variable there. And then it's squared also. X over 14 and then squared. Remember, this means the whole cosine is squared. And then plus 13.89. Times dx. So this would tell you, let's say it was 35. If you plug in 35 here, you have the initial 500 plus what's the change from 0 to 30, the first 30 years of the goblin sharks. And then this integral would give you the change from 30 to 35. Year 30 to 35 was changed there. And this one applies for the interval 30 less than t less than or equal to 30. So notice, for just setting that up there, we didn't need to use our calculator yet at all. But we will, starting with part B. So it says to the nearest whole number. So certain of these applied problems only make sense with whole numbers, like if it deals with people or animals. You can't have a part of a goblin shark here. So what is the goblin shark population? Population notion at time 50. So we can use our piecewise function right here. And notice for 50, that would require us to use the second piece. So, because it's on that second interval, versus if it was time 20, we would use the first piece. So g of 50 would equal, the second piece was 500 plus integral from 0 to 30 d of x minus (44e) to the negative 0.02x dx plus integral from 30, and this is where we're going to substitute in the 50. That's why we had to change the variables to x here, because the only place we want to plug in the time here for t is right here in this upper limit. So it goes from 30 to 50. And this one is b of x minus, in parentheses here, 35 cosine of x over 14 squared plus 13.89. And then all times dx. Okay. And we use our calculator to figure out what that is. All right. So Let's go ahead and start with the 83 and 84. Let's go ahead and enter these functions in first. So let's first for y1 enter in the birth rate we're given. So 30 e to the 0.005, and remember all the t's we're going to put in as x in our calculator, x, close parentheses. And then for y2, well, we've got two components for d of t. And as far as I know, there's not a way to put in piecewise functions as a single function in your graphing calculator. So we'll have to put them in separately and then just apply the appropriate domains to them. So this one would be 44 e to the negative 0.02 times x. And then that'll be the first part of dt, and then y3 I'll make the second part of dt. So 35. And then here, you can't type it in your calculator with a squared here on the trig functions. Remember, this squared means the whole cosine of t over 14 is squared. So you have to put open parentheses, and then cosine of x divided by 14, close parentheses on the cosine, and then another close parentheses so that we can square this whole thing, and then plus 13.89. But before we graph it, let's change our window size. So the x minimum and x maximum, they usually tell you in the problem. In this case, they tell you the x minimum, it starts at times 0. And the upper limit of our death rate function is 50, so we just know what's happening from 0 to 50 years. The y min and max, though, they usually do not tell you what to put in your calculator. So you just have to look at the numbers in the functions and make an educated guess here. So we got 30 right here, 44, 35, plus 13. So you might not have the right window size to start with. Just play around until you can see the functions. There's not just one right answer here. So I'm going to go from, let's say, negative 60 to 60. Try that. And see if I can fit these in there. And then graph. Okay, so there's the first one. There's the birth rate, there's the death rate that just applies until 30, even though we see it more than that. And there's the second part of DHT that just applies on this part from 30 to 50. And I'll show you how to handle dealing with each part there in just a little bit. Okay, so there's our graphs there. Now we can go second quit out of there and evaluate this. Actually, let me put it in the Inspire first, and then I'll evaluate it on both. So for the Inspire, new document, add graphs, and let's put in our f1 of x. Well, for b of t was 30e to the 0.005t, so 30e to the x, 0.005x. Again, you have to type it in, even though it has a t here. This is f1 of x, so it has to be x. Enter, and then tab. F2 was 44e to the negative 0.02x, so 44e negative 0.02x. And then for, let's move this over here. For then y3, hit tab for f3, and that one was 35 cosine of t over 14 squared. Again, you got to put open parentheses here. Trig, there's cosine. If you want, you can put the fraction, so it looks like a fraction in there. X divided by 14. And then make sure you put the squared not here, but so the whole cosine gets squared. And then we've got plus 13.89. So here I don't see anything, again, because the window size is not correct. So to change the window size, menu, window zoom. Let's make it the same window size we made the other one. So 0 with X minimum to 50, X maximum. And let's again make the Y minimax negative 60 to 60. So there's our 3 graphs there. All right, now let's go ahead and evaluate this with both calculators. So let's go back to the 84 here. So I've got 500 plus math number 9, function integrate. And again, this looks like the older 84s or 83s. The newer one's going to look more like, even though you hit the same buttons, it's going to look more like the Inspire in terms of the format it shows you here. So on the older ones though, you first put in what you're integrating. B of X, that was Y1, so vars, Y variables, Y1, minus this was Y2, first part of D of T, and then comma, X is our variable. On the newer ones, you put it next to the D for dx. And then comma, lower limit 0, comma, upper limit 30. Close parentheses on that integral. Now let's put in the other integral, plus math number 9 again. Function integrate, and then we still have y1, but now it's minus the second part of d of t, which was y3. So vars, y variables, y1, minus vars, y variables function, y3. And then comma, x is our variable, comma, the lower limit is 30, comma, the upper limit is 50. And then close parentheses. And we get 379. Notice 0.4, so round to the nearest whole number. So just 379. Now, in other things that aren't like necessarily whole numbers, that aren't like people or animals or something, it's like the amount of water or sand or something, then you'll put it to the thousands place. But here, the 379, in this case, goblin sharks, which are a real animal, believe it or not. They live deep in the ocean, I believe near Japan. So they don't know that much about them. All right, then let's look at the same thing on the Inspire here. So then we can go doc, insert, calculator, and then we can type in the same thing, 500 plus, integral is right next to the number 9, integral from 0 to 30. And this was y1 minus y2, so our f1 in this case of x minus f2 of x. And then you put x here again. The newer 84s look like this format basically, except it'll be y1 minus y2. And then go out of the integral with the right arrow, then plus integral from 30 to 50. And then this one are f1 of x minus, this time f3, the second part of d of t, dx, and we get the same answer. All right, now let's take a look at part C. Part C is the one that takes the most work here. It says, to the nearest whole number, find the minimum goblin shark population. So whenever it says maximum or minimum but doesn't say relative or local, remember that really means it's talking about the absolute minimum. So that requires the derivative, which is a little more complicated here. It has two components here. So when we draw our number line, for the rate of change here, well, we've got endpoints of 0 and 50. And what's also going to be significant is the break point here of our piecewise function is 30. because the derivative is different on each of these pieces. On the first piece, the derivative here is d of t minus the top part, 44 e to the negative 0.002t. So we'll write that one here. Now let's focus on this first interval from 0 to 30. So then we'll look at the interval from 30 to 50. I'll show you how to handle this piecewise. Easiest if we do it kind of one at a time. All right. So from 0 to 30, start with the 84 here. Well, what we really want, our overall derivative, is the birth rate minus the death rate. So rather than graphing them separately, let's graph them together as a single function by de-highlighting, hitting enter on the equal signs, de-highlighting all three of these. So they're still in your calculator, but they won't graph them now. And then for y4, this is y1 minus y2. So let's enter that in, vars y variables y1 minus vars y variables y2. Okay. But before I graph it, again, we want to change the window size. Really, the only thing we need to change is the x min and max. Because this only applies from 0 to 30, so let's change the x maximum to just 30. And then graph it. And then we're looking at the graph of the derivative, so look at the y values. You can see they start off negative until they hit 0, and then the rest of the interval, they are positive. So let's write that on here on our number line. See, it's negative until some value I'll call a, which we'll figure out in just a second, or 0, and then after that, it's positive. Okay. Now let's look at how we do the same thing on the Inspire. So for the Inspire, go back to 1.1, the graphs here, and then hit tab. For first, let's go up. And for most of the Inspires, the newer ones, you're going to uncheck the box, so it's still in your calculator, but it's not going to graph. If you have a really old Inspire, you might have an eyeball here that you have to put a line through by clicking on it so that it doesn't show it, so you can't see it basically. And then for y4, we'll enter in f1 of x, and then minus f2 of x was the first part of the d of t function. Let's see if we get the same thing. Negative and then positive. Whoops, I forgot to change the window size, sorry. Menu, window zoom, window settings. And again, we should just change the x maximum to just 30. That only applies from 0 to 30. There we go. All right, now what we need to know is what is that a value? Because we're looking for the minimum, right? And you can already start to see, based on what we see here, if the first row is negative, we know it's decreasing, then positive increasing. So it goes decreasing and then increasing so far. So notice A is a potential minimum. We can see it's a relative minimum. So we do need to find that value. If it said maximum, then we wouldn't have to find it. So let's go ahead and see how we find that on both calculators. Notice it's really just the x-intercept here, which is also referred to as a root or a 0. So you go second, calc, number 2, 0. And then left bound, just choose something to the left of it using the cursor or typing in, I guess, enter, and right bound, something to the right of it. If you get tired of hitting the right arrow so many times here, you can also just type in a guess. I'm going to just guess 20. And then your guess just has to be somewhere between these. It doesn't have to be right on it necessarily. So we get A is 15.3196, rounds up to 320. So let's go ahead and write that down on paper. 15.320. And sort in our calculator. So you store just like you do when you find points of intersection. It's stored in there as the answer right now. So second quit, store, or if you don't, it doesn't pop up, you could hit second ANS first, and then store, and then alpha A. Okay, and let's see how we do the same thing on the Inspire now. So from the Inspire, you just go menu, analyze graph, and then 0. Lower bound, just click a little bit to the left of the 0, upper bound to the right of it, and it gives it to you right there. Then highlight it, var store as a. And if this isn't the way, you can kind of drag it and move it around here. All right, now let's look at the next part of the interval, from 30 to 50. So now our overall derivative, b of t doesn't change. You still have the same birth rate function. But what's different is now we have to subtract the second part of the d of t function from 30 to 50. So it would be minus this 35 cosine squared t over 14 plus 13, what's that for an error there, sorry. 0.89. So that's what we use on this next interval. So let's see how we do that on our calculator. So back to the 8384. Go to y equals, and now let's go ahead and, in case we need it later, I'll leave this y1 minus y2. I'll de-highlight it though. And for y5, now we want y1 minus y3. So vars y variable is y1 minus y3. And before we graph it, let's change the window size. Again, it's the x min and max we really need to focus on. Because now, make sure we're not looking from 0 to 30, it doesn't apply there, it applies from 30 to 50. So x minimum 30, x maximum 50, and graph. So you can see it starts off positive, hits 0 there, and then becomes negative. Yep, the rest of the way, it never quite becomes positive again. So, at 30 it stays positive until someplace I'll call b, where it's 0, and then it's a negative the rest of the way. So you can see it keeps increasing here until b, and then it decreases the rest of the way. So based on that, in addition to a, notice the endpoint. When you're doing absolute minimax, you also have to look at the endpoints. In this case, notice 50, that's also a potential minimum. So we'll have to figure out which one of those two has a lower sharp population. If it was a maximum, we'd look at 0 and b. So there's actually no need to find b in this case, because it's not a potential minimum, it's a potential maximum. And we're not asked about that, even in the later parts of this question. So let's see how we do this on the Inspire now. So for the Inspire, just hit the tab button here, go up, uncheck F4, so we don't see that one anymore, and then for F5, tab, var f1 of x minus f3, oops, keeps hitting the wrong thing. Sorry about that. All right, so now we'll go var, there it is, f1 of x minus var f3 of x. And again, let's well, we hit enter here, and then this is now correct here. We got to change the window size here. Notice it starts off negative, which is not what we saw in the other calculator, because the window's from 0 to 30 right now, and that's not what we're looking at. So menu, window zoom, window settings, and now we want the x minimum to be 30 and the x maximum to be 50. So now you can see the same thing here. And then to find that 0 there, you go menu, analyze graph, 0. Lower bound, click to the left of it with your vertical line. Upper bound to the right of it. Oh, sorry, we don't need to find that either. My bad. Because that's B. We don't need to find B, I forgot. That would just show you it's positive and then negative. No need to do that in this case. All right, so that would be how you find B if we needed to find it. Now let's compare the Goblin Sharks, which was g of t, our original function that we wrote down in part A, of A versus 50. All right, So for g of a, notice a is 15.320. So if you go back to part A, we would use, that's between 0 and 30, we would use this top piece. So the initial is 500 plus the integral from 0 to A, which is stored in our calculator. Let me see, did I store that in the Inspire? I think I might not have here. Yeah, I think I forgot to do that here. Let me go back to the Inspire real quick. I found this one here. Let me go back. Menu, let me go back. Sorry about that. Tab. Uncheck this one for a minute and recheck this one and change the window size back to 0 to 30. Okay. Oh, I guess I did find it. I did store it after all. I forgot it. Okay. So then we'll have b of t, or I guess you write b of x here, minus the first piece, 44 e to the negative 0.02x times dx. So let's see what our calculator gives us for that one. So let's do this on the 84 first. So you have 500 plus math number 9, function integrate. Now you could put y1 minus y2, or you might remember we already made that y4. So it's actually a little faster if you just go vars y variables y4. Because that is y1 minus y2 already, comma x, comma lower limit 0, comma upper limit alpha a. And we get 397. Notice this doesn't round up here. So it'd be 397 Goblin sharks. And then we have to compare that with G of 50, the potential minimum. But remember, we actually already figured that out in part B. G of 50 was 379. So there's no need to do that again, because we already found it. And since we're looking for the minimum, you're looking for whichever is the lower of the two. In this case, if 379 is less than 397. So it asks for the nearest whole number of minimum Goblin shark population, so we can say the minimum Goblin shark population is 379, that's the actual population. And since we're justifying it here, it's probably a good idea to mention the time too, even though it didn't ask for what time. Sometimes it would. We can say at t equals 50, the units for time here are years. And then your justification, all you have to say is since, what we just found here, g of 50 turned out to be less than g of a. Are the possible place the minimum would be. So those definitely take the most work there. It's a little harder with a piecewise function. Now let's take a look at, well actually let's put this in the Inspire first, before we go to the next part. So the Inspire, again you would just enter in 500 plus integral from 0 to a. And again, you could do y1 minus y2, or that was our y4. You get the So now let's go to part D. Part D says, what is the rate of change? That's just another word for the derivative. Rate of change of the goblin shark population in the ocean at time 35. And then interpret your answer in the context of the problem and indicate units of measure. So again, there's two components to the rate of change, the birth rate and the death rate. The birth rate increases the amount of sharks, death rate decreases the amount of sharks. So we're just trying to figure out what they are at 35. So putting those together, this would be B of 35 minus, it is D of 35, but you have to make sure you use the right piece. So the way to show that you're using the correct piece would be, well, 35, that's on this interval, right? So this would be minus 35 cosine of 35 is what we're plugging for t right there, over 14 squared plus 13.8. So let's figure out what the answer is first, and show you guys how to do this on your calculator. So let's start with 84 again. So here, this B was y1, so I have to go as, actually, you could go, let me show you a couple different ways. Y1 of 35 minus, this was y3, so y3 of 35 gives you negative 0.617 if we run it. And the units for both of these are goblin sharks per year, so that's what it is. Or actually the other way you could type in, let's save you just a little bit of time. Remember we already put in y1 minus y3 is y5, so you actually could just go vars y variables y5 of 35. So we get the same thing. And then very similar on the Inspire here. You can either go F1 of 35 minus F3 of 35. Or you can go, since we had F5 of 35. Either way. All right, so then it says to interpret the meaning of your answer in the context of the problem and indicate units of measure. So whenever you're interpreting the meaning of a derivative, they want you to understand the importance of whether your answer is negative or positive. In this case, it's negative, so that means the goblin shark population is decreasing, versus if it was positive, it would be increasing. So the way we can word this is say, at t equals 35 units per time or years, goblin shark population is decreasing and then specify how to add a rate of 0.617, and then the units are goblin sharks per year. Notice I left off the negative sign, and I did that on purpose. That was not a mistake, because we said it's decreasing at this rate. So we already indicated the negative in the word decreasing. If you actually put a negative here, that would actually be considered incorrect. Because if you say it's decreasing at a negative rate, that's like a double negative in a way. Like saying I did not do that, it means you did do that. So decreasing at a negative rate would actually mean it's increasing. So whenever it's decreasing, if you use the word decreasing, you don't put the negative in the number there. Otherwise it cancels out the word decreasing essentially. All right, and then the last one here This is another useful tool with the graphing calculator. It says find d prime of 35. So you could do this partly by hand here and actually find the derivative. 35, notice, involves the second piece. You'd have to use the double chain here because it's cosine squared, so it's not that bad of a derivative. And then plug in 35. You could do that. Remember, there's a big time saver that they expect you to utilize on the AP test to save time. And that's the numerical derivative. So let's see how to do that on both calculators. So on the 84 first, you hit math, and then you go down to number 8. That's n-deriv, stands for numerical derivative. And the format is very similar to the integral one. Again, this is what the older ones look like for the 83 and the older 84s. The newer one's going to look more like the Inspire, but you hit the same button, math number 8. And then what we're taking the derivative of is just this second part here, right? Because 35 here. If it was d prime of 10 or something, we'd use the top piece here. So it'd just be y3 here, not y2. And then comma, x is our variable. And here, unlike the integral, we're only plugging in one number, 35. There's not a lower and upper limit. And this will tell us the derivative specifically at 35 is 2.397. So we get d prime of 35 is 2.397. And remember, d of t was already in Goblin Sharks per year. So the units, when we take the derivative, it's going to be Goblin Sharks per year. Remember, every time you take the derivative, you divide by the units of, in this case, time, the independent variable. But instead of Goblin Sharks per year, which you could write, usually that would be written as Goblin Sharks per year squared. Kind of like acceleration. And let's see how we do the same thing on the Inspire here. So the Inspire, I think there's different ways to get it, but one way that I think is probably the easiest is to go menu and then calculus, and the one that says derivative at a point. The variable is x, and here's where you can type in the value, in this case 35, and we want the first derivative, okay. And then right here, notice it already puts d over dx here for you, the x goes right there, and it already is putting the vertical line here with x equals 35, so all you have to do is put what function you're trying to take the derivative here. In this case it was f3, so var f3 of x, and hit enter, and it gives you the same value there. So this time, to explain the meaning of it, well, we can say something like this. This means at t equals 35 years. Well, now it's the derivative of the derivative, right? It's the derivative of the death rate, is what d of t represented. So it's not telling us that the Goblin Sharks are increasing. It's telling us that this rate d of t is increasing, because that's what is the derivative. So we can say at t equals 35 years, the death rate of Goblin Sharks is increasing at a rate of, what we just got there was 2.397 Goblin Sharks per year squared. And again, if you took the derivative again, the units would be Goblin Sharks per year cubed and so on. And that concludes the notes for AP Calculus on the topic of real-world rate of change problems continued.